So, good morning to all. Yesterday we have defined the reciprocal lattice vectors for the direct lattice vectors, and we have also seen on the blackboard how to construct the reciprocal lattice. So, reciprocal lattice, reciprocal lattice or space lattice, the reciprocal space lattice is a set of imaginary points constructed in such a way that the direction of a vector from one point to another coincides with the direction of a normal to the real space planes, and the separation of those points is equal to the reciprocal of the real interplanar distances. So we know the direct lattice. We have defined the direct lattice, the arrangement of point in space. Number of times we have defined it. So the reciprocal space lattice can be constructed by drawing a normal to each set of parallel planes from any arbitrary origin. So the length of this normal should be equal to the reciprocal of the interplanar spacing. Reciprocal of the interplanar spacing. Therefore, the points which we obtain by drawing a normal to the set of parallel planes, and the length of this normal is equal to the reciprocal of the interplanar distance. It is the most important. The length of the normal is equal to the interplanar distance, and the direction of this normal coincides with the direction of the in which we are drawing the normals. So the reciprocal space lattice is a set of imaginary points. So again, you will get a set of imaginary points constructed in such a way that the direction of a vector from one point to another. So if you consider any vector from one point to another, the direction of normal will coincide with that vector in the real space, and the separation of these points is equal to the reciprocal of the interplanar distances. So from there are 4 steps to construct the reciprocal lattice. First is choose origin at some arbitrary point inside the direct lattice structure. From any point you can draw normal to each and every set of parallel planes of direct lattice from the chosen origin. So in a given crystal structure, choose any arbitrary point as your origin and draw normals from this point to each set of parallel planes, and the length of this normal should be equal to the reciprocal of the interplanar spacing. So the unit of this reciprocal is per centimeter or per meter. So the endpoints of these normals form the reciprocal lattice point. So once you draw the normal, you will get the reciprocal lattice points. So this is about the reciprocal vectors. Let us see another point here. Screen दिसतोय माझा? हॅलो,
नाही सर.
स्क्रीन दिसतोय का?
नाही सर, ब्लँक दिसतोय.
आता
हो सर.
Okay. So let us define the reciprocal lattice vectors and the direct lattice vectors. So what is the relation between the reciprocal vectors and the direct lattice vectors? Let us see. So for that, define reciprocal vectors A star, B star and C star. आपण reciprocal vectors आहेत, तर reciprocal लक्षात येतो तुमचं की समजा A is the vector, its reciprocal will be 1 upon A. So let us define the reciprocal vectors denote these reciprocal vectors by A star, B star and C star. आणि त्याचे corresponding direct lattice vectors काय A, B, C. So for the direct lattice vectors A, B, C, the corresponding reciprocal vectors are A star, B star and C star. Now these are the non-zero vectors concurrent at a point. These vectors may be considered as the primitive translation of some lattice. आपण या vectors ला काहीतरी primitive translation vectors assume करूया. Now define vectors A star, B star and C star. आता आपल्याला माहिती आहे की A, B, C these are the direct lattice vectors आणि त्याचे corresponding reciprocal lattice vectors काय घेतले आपण A star, B star आणि C star. तर यांचं let us define vector A star, B star, C star such that A in dot A star is equal to B dot B star is equal to C dot C star is equal to 1. So what does it mean? The dot product of these two is 1. So A into A star, B into B star, C into C star is equal to 1. So what is the dot product? Dot product, suppose there are two vectors A bar and B bar, and the dot product of these two vectors is AB cos of theta. AB cos of theta. So where theta is the angle between the two vectors. So if the two vectors are parallel, then the angle between them is 0, and therefore cos 0 is 1. So here A star, A into A star is equal to B into B star is equal to C into C star is equal to 1. This indicates that the dot product is equal to 1. So this represents a reciprocal relationship. This represents a reciprocal relationship because from this equation we can write C is equal to 1 upon C star, B is equal to 1 upon B star, A is equal to 1 upon A star. That is the reciprocal relationship is proved here. So that means the direct lattice vector A and its reciprocal lattice vector A star, their dot product, if it is 1, then A and A bar, A and A star, that is the direct lattice vector and the reciprocal lattice vectors coincides. They coincides, and therefore the angle between them is 0. Therefore cos theta is equal to 0, cos 0 is 1, and therefore A into A star is equal to B into B star is equal to C into C star is equal to 1. So this is the identity. So this gives the reciprocal relationship between the direct lattice vector and reciprocal lattice vector. आणि समजा आपण घेतला की हा A आणि B star, if you take different directions, A dot B star, A dot C star, B dot C star, or B dot A star, or C dot A star. So that means here the dot product is 0. Dot product is 0. That means the angle between them is 90 degree. So theta is 90 degree. So that means A and B star, if A and B star are perpendicular, then their dot product is 0. If A and A star, their dot product is 1, they are parallel. So A and B star means the vector A and B star, they are perpendicular to each other. So we can now from this 1 and 2, so this gives the inverse relationship. So from equation we must have A star, A dot B star लिहिणं काय किंवा A star dot B लिहिणं काय किंवा A star dot C लिहिणं काय is equal to 0. So here A star is perpendicular to B and A star is perpendicular to C. That means A star is perpendicular to B and C. Perpendicular to B and C. From this identity, कारण काय हा डॉट प्रॉडक्ट 0 आहे. डॉट प्रॉडक्ट 0 केव्हा असतो ज्याला दोन वेक्टर्स हे परपेंडिक्युलर असतात. म्हणजे A स्टार B हा परपेंडिक्युलर आहे, A स्टार C हा परपेंडिक्युलर आहे, म्हणजेच A स्टार इज परपेंडिक्युलर टू B and C. So A star is perpendicular to B and C. आता A star is in the direction of B cross C. आता A star ची डायरेक्शन कुठे असेल B cross C च्या डायरेक्शनला असेल. That is perpendicular to the plane of B bar and C bar. Thus we can write, म्हणजे आपल्याला A star कसा डिफाइन करता येईल, A star is equal to, so we can write A star is equal to S B cross C, कारण A star is in the direction of perpendicular to the B cross C, where S is some scalar. S is some scalar. So A star is equal to S B bar cross C bar, where S is some scalar multiplier. आपल्याला हा S ची व्हॅल्यू काढायची आहे, म्हणून टेकिंग द डॉट प्रॉडक्ट ऑफ दिस विथ A स्टार, म्हणजे हा A into A star is equal to S हा ए आपण घेतला ए बार डॉट बी बार क्रॉस सी बार इज इक्वल टू 1, कारण हा ए डॉट ए स्टार काय 1 आहे, वरती आपण आयडेंटिटी घेतलेली आहे ए डॉट ए स्टार इक्वल टू 1. So A dot taking the dot product of this equation with A star, A dot A star is equal to S A bar dot B bar cross C bar is equal to 1, because this is identity is 1, A dot A star is equal to 1. So from this equation S is equal to 1 upon A bar dot B bar cross C bar. So S is equal to 1 upon A bar dot B bar cross C bar. आता हा जो A bar dot B bar cross C bar आहे याला काय म्हणतो आपण बॉक्स प्रॉडक्ट or scalar triple product. This is the box product or scalar triple product. Now put this value of S in equation above. So if you put S, value of S as this 1 upon A bar dot B bar cross C bar, then you will get A star is equal to B cross C upon A bar dot B bar cross C bar. See, this is the reciprocal